So in this problem, we have a voltage source which is connected. It's a 10 volt voltage source which is connected to a 10 kilo ohms resistor. It's connected again to a 5 kilo ohm resistor and branched out 2 kilo ohm resistor. And you got another voltage source here which is 5 volts. Alright, I guess I just lost my question somewhere. I'm gonna clear everything and then rewrite that again. So I got 10 volt source, do not mind my handwriting. So it's 10 volts here, 5 volts here, 5 kilo ohms here, 10 kilo ohms here, and 2 kilo ohms here. All right. So the question here is to find the current through this 5 kilo ohm resistor. Right? So basically, once again, we're looking at a scenario which is similar to the last time. If you had to select a resistance of a particular current rating, you need to know what is the current that's going to be flowing here. All right? So if you want to know this current, you got to do the nodal mesh analysis in this case. So I'm going to hook up an ammeter, and this is, we got to know what's the current flowing through that, right? So this is something called a mesh analysis, where you would typically use your Kirchoff's voltage law. So this is going to be one mesh, and this is going to be another mesh. So I'm going to assume we have current I1 flowing through this mesh. So when you have mesh, just one mesh, I'm going to consider just this. All right, nothing of that sort. So this is going to be my mesh 1. And then once again, I have another mesh right here. This is going to be my mesh 2. So let's go ahead and write the equations for mesh 1 and mesh 2. So for mesh 1, if I wrote the equation for Kirchoff's voltage law, I would have 10 volts, which is supplied by the power source, and it's going to be dissipated by voltage drops, which is 10 kilo ohms times I1 plus 5 kilo ohms, 5 kilo ohms times I1. I'm going to consider this current flowing in this mesh as I2. So I'm sorry. All right. So why I raised that was I had my currents flowing in the clockwise direction in mesh 2. That would mean it's opposing the voltage source here. So it's simply better to keep it in the direction of voltage source. It's not wrong to keep it in the opposite direction. Only if you get a negative answer, it means the direction is opposite to what you had initially assumed. So I'm going to assume the current is flowing in the direction of my voltage source. So here, if you look at it, if you look at the 5 kilo ohm resistor, all right, you got two currents. You got your 5 kilo ohms resistor here. You got your I1, and you also got your I2. So the potential drop across this would be 5 into I1 plus I2. All right. So that, if you go ahead, let's go ahead and solve this equation. So you would get 10 is equal to 15 times I1 plus 5 times I2. And since there are two meshes, you would typically get two simultaneous equations. So what I'm going to do is, you can use your calculator to solve simultaneous equations, but I'm just going to divide this whole equation by 5. So I would get, and rearrange the terms, so I would get 2 is equal to 3 times I1 plus I2. So you can keep it this way and solve simultaneous equations later, or I'm just going to move one term here. So I would get I2 is 2 minus 3 I1. Okay? Let's make a note of this. Sorry, I'm going to use the color that I used for mesh 1. Alright, yes sir. So I1 I2 is 2 volts minus 3 times I1. Alright, so let's go ahead and write the equation for mesh 2. So for mesh 2, I would have a voltage or an energy supplied, which is, let's see if there's a way to divide these. Alright. So this is going to be mesh 1. This is going to be mesh 2. So I got 5 volts, which is the energy supplied to this mesh, and it is dissipated by the current I2 flowing through the 2 kilo ohm resistor. So it's 2 times I2. And also, once again, you would have I2 flowing in combination with I1. So I would just add these two currents, and that is flowing through the 5 kilo ohm resistor, which is causing a voltage drop. All right. So according to the law of conservation of energy, we got this equation. So if I went ahead and simplified this equation, I would have this right hand side is equal to 7 times I2. This is a plus. So I would have 7 times I2 plus 5 times I1. So difficult to get these things precision. So this is going to be 2. Right? So if I substituted the value of I2 here, so I2 is 2 minus 3 times I1 plus 5I1. And once again, let's go ahead and solve this. So I would get 14 minus 21 plus 5 is minus 16 I1. So I'm just going to shift the I1 term to the left side. So I would get 16 I1 is equal to 14 minus 5, which is just 9. And I would get I1 is equal to 9 by 16, which is, how much is 9? Okay. According to my calculator, it's 0.56 milliamperes. So this is my I1. So if I went back and substituted the value of I1 here, I would get my I2 is 2 times 2 volts minus 3 times, I'm doing it in my calculator right now, I would get 0.32 milliamperes. Sorry, this is I2. So I got my values of I1 and I2. I'm gonna erase this. I'm gonna use this space here. All right, so let's find our final answer. To find the final answer, the question was, what is the current flowing through the 5 kilo ohm resistor? So we have I1 from our first mesh and we got I2 from our second mesh, and the current flowing through the 5 kilo ohm resistor is just going to be, I'm going to call it I. So this I through the 5 kilo ohm resistor is going to be I1 plus I2. So if you add I1 and I2, it's 0.56 plus 0.32, which is 0.88 milliamperes. That is your final answer. All right, let's quickly run through this again. So you had your mesh 1 and your mesh 2. So according to mesh 1, the energy is supplied by 10 volts. You got I1 flowing through the 10 kilo ohm resistor causing a drop, and you got I1 and I2 flowing through the 5 kilo ohm resistor in the same direction, hence the plus sign. All right, you got the same direction, hence the plus sign. So if you solve this equation, you get an equation like this. You can get two sets of equations and solve them using your calculator to get values of I1 and I2, or you can find the value and substitute it in the other mesh and get the value. And it's a lengthier process, but it's something that you do not need to. What I do on my calculator, I cannot show you that. All right. So I got my I1, I got my I2, and if I add them, that is it. So what is the implication of this? You got a current of 0.88 milliamperes flowing through the 5 kilo ohm resistor. So if you want to select a 5 kilo ohm resistor and you got a 5 kilo ohm resistor which has a current rating of 1 amperes or a current rating of 1 milliamperes or a current rating of 5 milliamperes. Actually, no. Or 10 microamperes. Right? So you got three options. So which resistor do you pick? How do you know what's the current flowing through that? So if you do your mesh analysis, you know the current flowing through it is 0.88 milliamperes. So it's pretty much sufficient to select something slightly higher than 1 milliamperes. So that is going to be a correct option to choose. Alright guys, so thank you for watching this video. Good luck on your fundamentals of engineering exam, and just know everything that you learn in your classroom has an application.